Hello, I'm Professor Julio Rezende, and today is August 3rd. I'll be talking about the main station on Mars, August 3rd of 2023, and how would be the operation of the main station on Mars. We can see a concept imagined by European Space Agency, like three stages of the operation of a station on Mars, on Moon. For example, first moment of survivability with a minimal crew, permanent presence, critical hardware only. For example, here we imagine a station with only 4 astronauts, for example. And the second moment, call it the sustainability stage, when we have a larger crew, additional less critical hardware, in the for midterm of operation of this station on Mars. In this case, our Habitat Marte is imagining this concept of a station on Mars based in this second moment. Okay, with a crew, we are imagining the entire station concept. A crew of 28 astronauts. We have uh, 7 facilities, and in this imaginary station that we are bringing here, with 4 astronauts in each specific station. After this second moment, will be possible imagine stations in the future operating with many multi-facilities in a Mars or Moon landscape. And this will be more complete crews with more higher diversity of hardware. In this case, this is the concept of proposed by us. Also, this is a design done by Yashirato, architecture from India. And we imagine 7 facilities: the police station, the engineering facility, the sanitation center, the greenhouse, the health facility, the main station, and the launch center. In this presentation, we will be talking specifically about the main station, how would be the operation of the main station. And we imagine also that main station would be the first infrastructure built on Mars. Related to internal design, we received a collaboration of a design student from Brazil. Her name is Mariana Guerra, and Mariana Guerra proposed that would be nice if we imagine not a circular shape, but hexagonal shape, that the faces of each hexagon would be possible about easily connect these hexagons. And also she did a good analysis related to one model. Maybe would be not enough to receive all astronauts, the crew of 28 astronauts. And she designed 3 different models connected. The first model, the alpha model, the second beta model, and the third model, the gamma. The alpha model is for relaxing. There is a bedrooms and study room. The second model, the beta, is for entertainment and dining. There is a kitchen, dining room, and living room. And the third model is the gamma, is for control center and support operations for entire station. And there is also here the mission control. In this case, the alpha model is present 14 bunks for the astronauts. Is the place when everything is working in the station, is where the all astronauts will come together to rest. Also, there is rest rooms here, okay, and the study rooms distributed in 3 levels, okay, 3 floors. We present a challenge about cultivate plants aboard. Some reasons about we have tried to have plants inside the stations is related to evaluation of air quality. Also brings nature to space habitat. This is related to psychological well-being, less stress, and more health and well-being. And the possibility of vegetables productions bringing practicity and easiness to prepare a fresh meal, the pick and eat concept, and help. These plants also can be helpful for meditation. These are a concept of dormitory, where the astronauts would be sleeping. Also, for the study room, it's possible to have physical books, some of them, but also the content of books and can be available in digital format. And related to digital content available in the station, maybe it would be nice if you have like a great quantity of data of books, movies, and music for the entertainment of astronauts. The second model is the beta. And in this case, in the beta, we have the kitchen, the dining room, and tables for 10 astronauts. We would have shifts for the astronauts lunch, and also a living room in the second floor, in the third floor, a gym, okay, distributed in these levels here. This is a concept proposed by Michael Lowry in the platform called Kitely. He imagined some a piano, a drums, and a swimming pool. And here is the kitchen, the possibility about we have some easily food to be collected, some vegetables. And here's just available a robot done by the company called Molly. And this robot can read the labels of the ingredients, also can follow some guidelines from a video in YouTube. Concept of a dining room and the gym. Also on the space, there is the equipments for workouts they are adapted. And the third model is the Gamma model. The Gamma model is for mission control. And here we have like the panels since the Apollo missions, short missions until Dragon. In the SpaceX capsule, we can see here like big screens and some systems, some software. When it's possible, you look the follow different parts that operate inside the station, also following the conditions from the Mars landscape. In this case, these computers will be very important to control many parameters operating in the station. We imagine a very important system, a dashboard to control the entire station, also seeing how is operating the greenhouse, the police station, the main station, the health, how is the health of astronauts, and observing the sanitation aspects. Here, we will be having integration with the greenhouse, because from the main station, we would like to know about the air, the quality of water, the temperature, the energy, how is the consumption of energy and water, how is the soil conditions, what are the crops, how is the quantity of and quality of the vegetables produced in the greenhouse. And it's very important to have a conversation with the greenhouse chief to have these informations. Also, we need to know a lot of information in terms of health of astronauts, And from main station, we are following the levels of water, food, temperature, the humidity, and quality of the air in the station. And we are following the conditions during the extravehicular activities. How is the weather, temperature, lightning, wind and dust storm, and how is the operation of extravehicular activities. And if you have like astronauts doing extravehicular activities outside of the station, you need to know if there's some threats to them, if they are safe. And yes, and also very important, have follow the operation of power station to understand how is the consumption of energy in the station, how is the production of energy in the power station. The other example here, the connected with sanitation. We need to know how is going the production of water, oxygen, also the treatment of the sewage, and some aspects like this. In the main station, we are in this facility. We are talking about the gamma model and the it's like the mission control center. That is a research room to support some analysis. Okay. And this is a little about how would be the concept of the main station in terms of design. The second part of my presentation is related to applied technologies. We imagine that some technologies operate in the main station, for example, the kitchen, the entertainment area, the control center, and depending of each specific facility, there is a different resources. Possible resources to generate in situ or transported from Earth. Almost everything will be transported from Earth. Some utensils would be 3D printed on main station, and part of food would be produced in Mars greenhouse. The third dimension of my presentation is the management. We imagine in the main station the commander, the executive chief, a chef, and a general assistant. The commander would be someone with a multidisciplinary background, someone from management or industrial engineering, a high capacity of leadership, intercultural competency, high personal resilience. And some duties are control of extravehicular activities, propose routines and operational protocols, provide guidance to avoid the risks, conduct educational activities, preparations for EVAs, and coordinate daily communications routines with NASA, ESA, ISRO, and other space agencies from Earth. Okay. Also, the command established communications with sometimes with specific facilities, sometimes with the crew, and sometimes with specific astronauts. The second position is the executive chief as someone to support the commander and working together. And the third position is the chef. The chef would be a cooker, a cuisine chef, a nutritionist, or gastronomer. And some duties are define the menu, the meals, the food logistics, perform food preparation, waste disposal, cleaning, organization, maintenance, and repair procedures, assess the team's nutritional requirements, plan the viability of food, and define the feed shifts. We had a presentation of Dr. Sian Proctor in one of our space analog virtual missions, and she commented about the move the matrix. In the matrix movie, in this photo here, Neo is inside the ship Nabucodonosor, and she's eating oat milk here. and she's very bored. It's because every day is the same meal. He's very tired about the situation. And Dr. Simon Proctor was mentioned that would be interesting. We have different kinds of meals, different kinds of ingredients to be operating these the preparation of the meal for the astronauts. In the last two photos, we are showing here in the second photo the pre-prepared meal transported from Earth, okay, in plastic package that will be normally there is an infusion of hot water inside these plastic bags, and these meals recover the properties. In the last photo are showing some ingredients produced in Habitat Marte greenhouse in Brazil. For example, like pepper and basil, and would be interesting for the future combine these two kinds of ingredients transported from Earth, and also ingredients produced in the greenhouse on Mars. The last positions is an assistant that will be also present support for the operation of the station. Okay, we imagine this sixth part of my presentation. How would be the astronaut training program? Some topics would be the new skills based on situations identified on Mars, systems operation, new technologies, positions and tests of each astronauts, and simulation. Related to YouTube videos, I imagine for example, a video mention about how to work in groups, how to manage mental health, about music, for example, Baroque music, but other styles too, occupational safety and health, and building resilience. These would be some topics that will be covered in our training of astronauts. Related to resources for 1 week, we imagine like 1 kilo of food for each astronaut, 4 liters to drink, and 2.2 liters and half to prepare the meal, and also more 2 liters to the bath of astronauts by day. This case around 10 liters for each astronaut by day. If you are considered 1 week, would be like 70 liters available by day and 7 kilos of food for each astronaut. Guidelines to be provided to other facilities. From the management, we would like to propose daily routines and schedule activities, stimulus for cooperation, innovation, creativity, and co-creation. Also topics related to health, environment, and safety guidelines, and how to maintain vertical guards in some facilities. Related to quality of life, health occupation, harmony, and a collaboration, how to let astronauts comfortable about being in space, well-being through interesting content to entertain the crew, and self-sustainability, each one observing self-organization, self-maintenance, self-fixation, and alerting others. Okay. This is now I will be presenting the fourth part of my presentation related to protocols. We imagine some specific protocols operating the main station related to harmony and good relationship, deal with stress, organize the room, food production and plant maintenance, infrastructure maintenance, water savings, and energy saving. Associated with protocols of safety and health, we consider important the hygiene protocols, wearables data collection, for example, using the Apple Watch to follow the heart rate, also calorie consumption, physical activity level, health data collection like for saliva, blood, and feces, and urine, psychological balancing and emergencies, and simulation for accidents. This is like a smart toilet that since you are using this smart toilets, he will be doing analysis of the urine and the feces, and also providing doing analysis and providing the data. How is your health condition? In terms of occupancy and entertainment, we'd like to celebrate the birthdays, the parties, also celebrate some important days according to the culture of the participants, like Diwali and Holi parties celebrated on India. Also, Dia de los Muertos from Mexico. Also, see how would be an important day celebrated in Turkey. Also, Carnival from Brazil.
Não encontrei Celebrate na biblioteca.
Also, Halloween from United States, Christmas, New Year's, and other dates. Also important for entertainment, like a free day for spa day, use of board games, yoga and workouts, mindfulness protocols, and content suggestions based in terabytes of music, movies, and books. This would be a concept of a vertical garden. Also for vertical garden would be important a protocol for microfood production related to protocol for cultivation, protocol for maintenance, also food harvesting protocol, protocol for rotation, best time for irrigation, male, female flower pollination, and about the plant cycle. Here are some teas to be produced on Mars, like fennel, green tea, and meat. Would be interesting. We have like some ingredients for the beverage inside the station. And now about the 3D printing. The first two photos is it's a ceramic 3D printer. It's using like a clay, a soft clay, used inside this tube, and there's a nozzle here producing layer by layer of utensil like a ball. In this case, we will be collecting the regolith in the Mars landscape and treating this regolith, cleaning, purifying, and also using the transforming the regolith in a clay to print these utensils, for example, like here. Also would be important in the main station the 3D printers to print using plastic filament. And also there is a key example of 3D printer, a clay 3D printer, and also a metal powder 3D printer, okay? Also for 3D printer, we imagine that to print some materials or utensils would be very important, have different CAD programs, CAD projects. And also imagine a protocol for product degradation and recycling. Like, for example, discarded items are ground down to particles. Ground plastic are further refined into smaller particles in a blender. The small particles are melted and extruded into a plastic filament for 3D printing. And then happens the additive manufacturing process with recycled filament. Okay, the last part of my presentation are the spin-offs. We imagine like some technologies for sleep. This is a machine that is sucking the blood of the astronaut. One of the health problems uh, on space, also happening International Space Station, is the great part of the blood because uh, the the gravity, the blood stays in the head of the astronaut. It is great quantity of blood in the head of of astronauts brings a lot of health difficulties. Also, for examples, they can develop the blindness because there's a lot of pressures in the blood in the eyes of astronauts. And it's very important this equipment like this to suck the blood of inferior members. Also technologies for food production. For example, this is a greenhouse aboard of the International Space Station called VEGI. Also technologies for learning. This now we have a Apple Watch, not this, so the model, but this would be interesting for using the augmented and virtual reality to be used on Mars. Also technologies for water savings. This is the urine processing assembly aboard of International Space Station. And it's very interesting to recycle the urine to save water. And also technologies for recycling. This example of blender. These would be technologies of the station on Mars that would be applied on Earth. This is the astronaut Scott Kelly. Scott Kelly did many presentations about how was his experience on aboard of the International Space Station. He lived around 1 year in the International Space Station, and during the pandemics, he presented some classes about how he deal about to live 1 year on space, and some guidelines to be applied to our daily life on Earth are related to health, environmental, and safety guidelines. Protocols are very important. Also, it's important to think about mental well-being and health occupancy. Also, think about daily routines and guidelines and recycling mindset. For example, 3D printing applications. And the last part of my presentations are the impacts to Sustainable Development Goals, the SDGs. We imagine the operation of Main Station would bring impacts related to health and well-being. This is the goal 3. Also, training of astronauts is connected with SDG 4, the quality education. Also, it's important women and men balance in the main station. In this case, if you are considering 4 astronauts, will be 2 men and 2 women in the station. Also, what we are operating is very connected to water saving and energy efficiency, the goals 6 and 7, and also waste recycling connected to goal 12. And management is associated with peace and justice. And 17 is the partnerships, the importance of partnerships, because we have crews from different countries working together in the base station. Okay, this is my contact, and thanks so much for the attention. Okay, I'll stop my presentation right now.